Hi, this is Halal. In this video on mathematical economics series, we will discuss about minors and cofactors. In earlier video, we have discussed about how to find the determinant of a 3 by 3 matrix. Now, the elements of a matrix remaining after the deletion process form a subdeterminant of matrix called minor. That is, the elements of the matrix remaining after the deletion process. In earlier video, I have explained the deletion process. Form a subdeterminant of a matrix called minor. That is, a minor, that is Mij written in these two lines, between these two lines written Mij, is a determinant of the submatrix formed by deleting ith row and jth column of the matrix. That is, a minor is denoted by this symbol. This Ij is the ith row, and this is the ith row, and this is the jth column. That is, the minor here will be, if this is the given matrices, then the first minor will be m of 1 1. That is, the first minor is equal to, we will delete the first row and the first column here, that is ith row and jth column. So the remaining sub matrix is A 2 2, A 2 3, A 3 2, and A 3 3. So this is a minor. Similarly, the second minor here is M12, M12. So here we will delete this first row and second column, and the elements here are then A21, A23, A31, and A33. Similarly, the third minor is, that is M13. Then this third minor is, that is deleting the first row and the third column. Then the remaining elements are A21, A22, A31, and A32. So here this M11 or M12 or M13, these are the minors of A11, A12, A13, these small a1. That is, I will write here this this M11 is, this M11 is here, the minor is denoted by these two lines also. So I will put this is the symbol for minor. Here it is also. So this is the symbol for minor. Now therefore M11 is minor of this element, that is A11. Similarly, M12 is minor of this element, that is A12, this second element A12. Similarly, M13 is minor of this third element, that is A13. Now the determinant can be written as, we can write the determinant like this is the symbol for determinant, can be written as, that is A11 multiplying this by the first minor, that is M11 plus A12 multiplying this by -1. We have seen in the earlier videos. So it is to be multiplied by -1 times the determinant, the second minor, that is m1 2. Similarly, this third element, that is a13 plus a13, and multiplying this by this third minor, that is m13. So this is how we write the determinant. We can write the determinant like this also. Now this a cofactor, this cofactor is, I will write the definition. So first I will erase this. Now a cofactor that is denoted by Cij is a minor. This is also a minor with a prescribed sign. That is, a cofactor is a minor. So this is also a minor, but there is a definite sign given, or a prescribed sign given. The rule for sign of a cofactor is, that is, if this is Cij is the this is the cofactor, then the sign of this cofactor is given by, that is given by -1 raised to the power I plus j. Now this I is the ith row and j is the jth column. Thus if I plus j, this subscript, the sum of the subscript is even number, then Cij will be equal to this minor, that is Mij. That is, if I plus j is an even number, this is an even number, this means this Cij, that is a cofactor, is equal to the minor. So that is minor, which is denoted by, which we have seen, Mij. Then if the sum of the subscripts is an even number, then Cij is equal to Mij, because -1 raised to the power even, raised to an even power, is positive. That is always positive. So we can say there is no difference between a cofactor and a minor when the sum of the subscripts, superscripts, that is ith row and jth column, the sum of these two numbers is even number, then there is no difference between minor and a cofactor. Now if I plus j, if it is an even, if the sum of these is odd, then this Cij is equal to -1 times the Mij. That is, this cofactor is equal to -1 times the minor, because -1 raised to the odd power is always odd. That is where this -1 came from. So we will take an example here. Now let's have an example on minors and cofactors. if we are given a matrix that is A is equal to A11, A12, A13, A21, A22, A23 and so on, these are the elements of this matrix A, then the first minor, which is denoted by this M11. Now this M11 is the minor at the place of A11, that is the minor of the first element, that is this is given by we mentally delete the row and the column in which the first element, this A11, appears and take the determinant of the remaining elements, that is A22, A23, A32 and A33. So this is the minor M11 in place of this element A11. Similarly, the second minor is denoted by M12. So this M12 is a minor in place of this element A12. Now the minor at this place is found by we mentally delete the row and the column in which this element appears and take the determinant of the remaining elements. Now if we delete this row and this column, we are with these four elements, that is A21, A23 and A31, A31 and A33. Now this is the M12 is a minor in place of this A12. Similarly, the third minor will be, that is M13. Now the third minor is found by mentally deleting the row and the column in which this A13 appears and take the determinant of the remaining elements. The remaining elements are then A21, A22, A31 and A32. So the third minor will be A21, A21, A22, A22, A31, A31 and A32. Similarly, the fourth minor is the minor in place of this A12 element is, so I will write here that M12. The minor at this place is this place, that is A12. We mentally delete the row and the column in which this element appears and take determinant of the remaining elements. The remaining elements are A12, A13. So I will write here A12, A13, this row and this column. So we have then A32, A32 and A33. So accordingly we can find the minor at place of A22, A23 by mentally deleting the row and the column in which the corresponding element appears and take the determinant of the remaining elements. Now the cofactor is a minor with proper sign, that is the cofactor at first minor is given by, that is the cofactor C11 is given by we take -1 and raise it to the power of the addition of the subscripts, that is 1 plus 1, and multiply this by this M11, that is M11. So giving a minor a proper sign forms the cofactor. So here in this case, -1 raised to the power 1 plus 1 is 2. So the -1 raised power 2 is +1. So the first cofactor have the same sign as that of the first minor. Similarly, the second cofactor, this C12. Now the second cofactor has the sign, the general formula is -1 raised to the power of the addition of the subscripts, that is 1 plus 2, and multiply it by the second minor. The second minor is M12. So -1 raised to the power 3 will be -1. So here the second minor will be negative, that is that is equal to minus times m1 2. Similarly, the third cofactor is given by c1 3, and the formula is we take minus 1 and raise it to the power of the addition of the subscripts, that is 1 plus 3, and multiply it with the given minor. Now the given minor is here m1 3, so I will write m1 3. So here 3 plus 1 is 4, minus 1 raised to the power 4 is plus 1, because minus 1 raised to the power of an even number is positive, and minus 1 raised to an odd power is minus 1. So here this is m1 3. So the first cofactor is, that is c. Here the first cofactor is here c11. This will be the positive one. The first minor was our so I will write here a22, a23, a32 and a33. Similarly, here the second cofactor c12 is equal to, now the second cofactor is, and the sign of the second cofactor is minus, as we have seen here. So this will be equal to minus times a21, a23, a31 and a33. Similarly, the third cofactor c13, which we have, the sign of the third cofactor is, here we have seen this is positive, and our minor at that place was this a21, a21, a22, a31 and a32. So accordingly we can find the sign of the minor. So the general formula is the cofactor, the sign of the the sign of the cofactor is, if we are given Cij, means the cofactor at ith row and jth column is equal to minus 1 raised to the power of the addition of the subscripts, that is I plus j, and multiplying it with the minor at that the corresponding minor, that is mij. So if I plus j is, if I plus j is even, then sign of cofactor is, then cofactor is positive. Therefore sign is positive, and if I plus j is odd, then sign of cofactor is negative. Why? Because minus 1 raised to an even power is always plus 1, and minus 1 raised to an odd power is minus 1. Here we can see, if I have minus 1 raised to any even power, that is 2, so this will become plus 1, and minus 1 raised to an odd power, let us say 5, so this will become minus 1. So this was now let's have a specific example on the minors and cofactors. That is, find, the first part is minors and the B part is cofactors for the elements of the first row. The question tells us to find the minors and cofactors for the first row. So the solution would be like this. That is, to find the minor, first finding the minor, this is the A part. Now the first minor here, that is denoted by M11. The first minor, that is the minor at this place. At the first place is, we mentally delete the row and the column in which the first element appears and take determinant of the remaining elements. The remaining elements are these 4 elements. So this is -3, 2, 7, 4. Now solving this, now this is -3 into 4, that is multiplying these 2 elements, and from there subtracting the product of these 2 elements. This is 2 and 2 multiplying it with 7. So this is 3 4s are 12 minus 12, and here it is -14. So now this is equal to -12 and -14 is, that is -26. This is the first minor. Now the minor at this position, that is at the second element, is that is denoted by M12. Now what we will do, we will mentally delete the row and the column in which the second element appears and take determinant of the remaining elements. The remaining elements are here 6, 1, 7, 4. So I will write here 6, 1 and 7, 4. Now solving this, now this is 6 into 4 and minus 1 into 7. So this is 24 minus 7, that is equal to 7, that is equal to 17. So similarly the minor at the third place is, that is M13, that is equal to, now mentally deleting the row and the column in which the third element appears, take the determinant of remaining element. So this is 6, 1 minus 3, 2. So I will write 6, 1 minus 3 and 2. Now solving this, this is 6 into 2, 6 into 2 minus 1 into minus 3, that is 1 into minus 3. So this is equal to 12. Now minus minus is plus, now this is plus 3. So here it is 12 plus 3 is 15. So these are the minors for the first row. Similarly we can find the minor for here, that is it is M11, M12, M13. Now here it is M21. So M21 is equal to, we mentally delete the row and the column in which this element appears and take the determinant of remaining elements. The remaining elements are 2, 2, minus 4 and 4. So 2, 2, minus 4 and 4. Now solving this, this is 2 into 4 minus 2 into minus 4. So this is 8. Now minus minus is plus, this is plus 8, this is 16. Similarly we can find the minor here, M22, M23 and so on. Now you can calculate others, because we were told to find the minors along first row. We have completed. This is, these 3 elements are on the first row. Now the B part is to find the cofactor. Now cofactor at this place is equal to, this is denoted by C11. Now cofactor is simply a minor along a proper sign. That is, here we write first minor, that is M11, and multiply it with -1 raised to the power of the addition of the subscripts, that is 1 plus 1. So this is equal to -1 square, that is -1 square times M11. So this is now -1 square is plus 1. So here the sign is positive, so I will write M11. So this is the first cofactor. Similarly the second cofactor is C12. Now this is equal to -1 raised to the addition of the subscripts, that is 1 plus 2 and the minor at that place, that is M12. Now here this is -1. Now this is 2 plus 1 is 3, M12, that is equal to now -1 raised to an odd power is minus, so -1 is minus, multiplying it with M12. So the cofactor here is m11, which we have calculated, that is minus 26. So there is no change in the sign. Here it is 17, m12, sorry, I will write here 17, that is 17, and here the sign is minus. So the cofactor C12, the sign is minus 17, and here we can see minor was plus 17 and it is minus 17. Now similarly, the third cofactor, that is C13, is equal to minus 1 raised to the power of the addition of subscripts, that is 1 plus 3, and multiply it with the corresponding minor. So that is m13. So this is equal to minus 1. Now 3 plus 1 is 4, m13. Now minus 1 raised to an even power is positive, that is here m13. Now our m13 here is 15. So this is 15. So there is no change in the sign. Similarly, the cofactor for C21, that is the cofactor at this place. This is also equal to minus 1 raised to the power of subscript, that is 2 plus 1, this, and multiply it with the corresponding minor, that is m21. Now this is minus 1 raised to the power, that is 2 plus 1 is 3. So, and multiplying it with the corresponding minor, that is m21. Now minus 1 raised to an even odd power is minus, so this is minus m21. Now our m21 was 16. Now the sign here is minus, so this is minus. And similarly, we can form a cofactor matrix. The cofactor matrix will look like this. So I will rub this. I should rub. Where should I write this? So I will rub this out. Now the cofactor matrix would look like this. The elements in the cofactor matrix will be, the first is C11, second is C12, third is C13, similarly C21, C22 and C23. This is equal to, if this is the cofactor matrix. If C denotes the cofactor matrix, then C is equal to, now the first cofactor was, the element is minus 26. Now here it is minus 17, and here it is 15. Then we have minus 16, and similarly we can find the other cofactors, because the question tells us to find the minors and cofactors for the elements of the first row. So we have calculated only those. In addition, we have calculated the minor for this element and its corresponding cofactor. I hope you like this video. Thank you. So for more videos on mathematical economics, please subscribe our YouTube channel Econ Maths. Also comment, like and share. Thank you.